pressure of fluids. This massive supertanker is one of the biggest ships ever to sail the ocean, filled with to capacity with oil, weighs more than 500,000 metric tons, well over 1 billion pounds. How can such a tremendous weight flow on water? Why doesn't it sink to the bottom of the ocean instead? Did you ever use a bicycle pump? Pump forces air to a tire through a small hole. Like other fluids, both liquid and gases, air can flow and take the shape of its container. Air that enters the tire from the pump quickly spreads out to fill the entire tire evenly. As the tire fills with air, it feels firmer. That's because the air exerts pressure against the inside surface of the tire, which is pressure. All fluids exert pressure like the air inside the tire. Particle of fluids constantly moving in all directions and random. As the particles move, they keep bumping into each other, into anything else in their path. These collisions can cause pressure. The pressure is exactly equal in all directions. Particles are crowded together in one part of the container. They quickly spread out to fill the container. They always move from an area higher pressure to an area of lower pressure. So air entering a tire spreads quickly throughout the tire. What is the relation between pressure, force, and area? Pressure is the result of force acting on a given area, can be represented by the equation. Pressure equals force divided by area. Pressure shows how concentrated the force is on a given area. Smaller the area to which force is applied, the greater the pressure is. Think about pressing a pushpin to a bulletin board. You apply force with your thumb to the board head of the pushpin. However, the force that pushpin applies to the bulletin board acts only over the tiny point on the pin. This is a much smaller area, so the pressure to the point that applies to the bulletin board is much greater than the pressure applied with your thumb. As a result, the pin penetrates the bulletin board with ease. What is SI unit for pressure? The equation for pressure, force is expressed in Newton and the area is expressed in square meters. Therefore, pressure is expressed in Newton per square meters, which is SI unit for pressure. This unit is called Pascal. This name for the scientist Blaise Pascal, who discovered pressure in fluids. Pressure may also be expressed in kilopascal, which equals to 1,000 Pascal. For example, the correct air pressure inside a mountain bike tire is usually around 200 kilopascal. How to calculate pressure or force? When you know how much of force is acting on a given area, you can calculate the pressure that is being applied to the area using the equation for pressure given above. For example, assume that a big rock weighs 500 newtons and is resting on the ground, an area of 0.5 meter squared. The pressure exerted on the ground by the rock is pressure equals 500 Newton per pressure equals 500 Newton divided by 0.5 meter squared equals 1,000 Newton divided by meter 1,000 Pascal or 1 kilopascal. Sometimes pressure but not force is known. To calculate the force, the equation for pressure can be written as force equals pressure times area. For example, suppose another rock exerts 2 kilopascal pressure over area of 0.3 meters squared. How much does the rock weigh? 2 kilopascal to 2,000 Newton per meter squared, and substitute it for pressure in the force equation. Force equals to 2,000 Newton divided by meter squared times 0.3 meter squared equal to 300 Newton. What is pressure in the ocean and the atmosphere? Both the water in the ocean and the air in the atmosphere exert pressure because of their moving particles. The ocean and the atmosphere also illustrate two factors that affect pressure and fluids. Fact pressure in fluids, depth and density. Fluid exerts more pressure at a greater depth. Deeper in a fluid, although the fluid above results in more weight of pressing down, causes a greater pressure. Denser fluids such as water exert more pressure. Less dense fluids such as air. Particles of denser fluids closer together, so there are more collisions in a given area. What is water pressure? As you go deeper in the ocean, pressure is exerted by water increasing steadily. Every additional meter below the surface, pressure increases by 10 kilopascal. The depth of greater than 500 meters, pressure is too great for human to withstand. Without special equipment to protect them, around 9 centimeters below the surface. The deepest part of the ocean, the pressure is tremendous. Because of the pressure of the water, divers will go deeper than about 40 meters below the surface. When they return to the surface slowly, stop for several minutes to one or more points their ascent. Instead, body just to increasing pressure of the water as they swim closer to the surface. Then, or to rise the surface too quickly, gas dissolving their blood will form bubble and cause serious health problems. What is air pressure? Water in the ocean, air in the atmosphere exerts pressure, increases with depth. Most gas molecules in the atmosphere are pulled close to the surface by gravity. As a result, the air pressure decreases quickly at a lower altitude, more slowly at higher altitude. The pressure is greater at sea level. The depth of the atmosphere is greatest. High altitude, the pressure is less because the depth of the atmosphere is less. For example, on top of the Mount Everest, tallest mountain on Earth, pressure is only about 1/3 of the pressure at sea level. Such high altitudes, the air pressure makes it hard to breathe and is dangerous to human health. The pressure of the air in the atmosphere allows you to do many things, from sipping through a straw to simply breathing. First suck on a straw, remove air from the straw so the air pressure in the straw is lower than the air pressure on the surface of the drink. Because fluid flows from the area of high to low pressure, the drink moves up the straw and into your mouth. When you breathe, the muscle called diaphragm causes the ribcage and the lungs to expand or contract. When they are expanded, air in the lungs is under less pressure than the air outside the body, so air flows into the lung. When the ribs and lung contract, air in the lungs is greater pressure than air outside the body, so air flows out of the lungs. What is the law of fluid pressure? Some of the earliest scientific researchers on fluid was conducted by a French mathematician and physicist named Blaise Pascal. Pascal was a brilliant thinker. Still, he developed important theorem, mathematics, and also invented a mechanical calculator. The Pascal's contribution to our understanding of fluid is known as the Pascal's law. What is Pascal's law? Pascal's law states that the change in pressure at any given point in enclosed fluid is transmitted equally throughout the fluid. Single example may help you understand Pascal's law. Assuming you have a small packet of ketchup, if you open one end of the packet and then apply pressure to the other end, what will happen? Ketchup will squish at the end. Pressure exerted on the packet is transmitted through the ketchup. When the pressure reaches the open end, it forces the ketchup out of the packet. The ability of fluids to transmit pressure this way can be very useful, besides preventing ketchup for your French fries. For example, the hydraulic car lifts contain fluids that transmit pressure and raise the car so the mechanic can walk out from it below. The fluid is used. Usually, type of oil can be compressed. Force is placed on the liquid in a narrow cylinder, and the fluid transmits the pressure throughout the hydraulic system. When the pressure reaches the fluid in the wide cylinder, it forces the cylinder upward along with the car. The force applied to the car is greater than the force applied to the fluid in the narrow cylinder. Why? When pressure acts over a wider area, it creates a larger force. Because force equals pressure multiplied the area over which it acts. You saw probably in the equation. Force equals pressure times area. Beside the hydraulic car lifts, other equipment that uses hydraulic fluid to increase force range from brakes to bulldozers. Even the controls in an airplane use hydraulic because of force multiplying effect. Flick of a switch can raise or lower heavy wind flaps. Landing gear, what is was a Bernoulli's law, an important law about pressure in fluids, still described by Daniel Bernoulli, a Swiss mathematician who lived during the 1700s. Bernoulli used mathematics to arrive at his law. Bernoulli's law states that pressure in a moving fluid is less when the fluid is moving faster. Bernoulli's law explains how the wind of both airplane and the birds creates a lift and allows flight. Shaping the wind causes the air to flow more quickly and the air pressure to be lower above the wing than below them. This allows the wind to lift the plane bird above the ground against the pull of gravity. Spoiler on a race car works in the opposite way. Shapes cause the air to flow more slowly and the air pressure to be greater above the spoiler than below it. As a result, the air pressure pushes the car downward, giving the wheel better traction on the track. What is the physics of sailing? Northern California has a story of 500-year history of sailing, but despite this rich heritage, scientists and boat designers continue to learn more today about what makes a sailboat move, contrary to what you might expect. Physics of sailing still presents some mystery to modern sailors. I make a summary. Fluid exerts pressure because their particles are constantly moving at a random direction and bumping into things. Pressure can be represented by the equation pressure equals force. The SI unit for pressure is Pascal, which equals to 1 Newton per meter squared. Two factors affect the pressure of fluids are depth and densities. This explains why water pressure is greater and deeper and in the ocean, and air pressure is greater at sea level. Denser fluids such as water exerts more pressure. Less dense fluid such as air, Pascal's law states that change in pressure at any point in closed fluid is transmitted equally through another fluid. This allows the basic hydraulic equipment such as hydraulic car lifts. Bernoulli's law states that pressure in moving liquid is less when the fluids move faster. This law explains how the wind of both airplane and birds can lift. That's it. Thank you very much. I'm the A major scale category number 2 and the Mozart quartet in C major. enjoy it.